Why, hello there. Today, I'd like to teach you about special factoring. Now, I know what you're going to say. Isn't all factoring special? And the answer is yes. But more special is the idea of perfect square trinomials and difference of squares. So let's get it going. All right, imagine I asked you to factor something like x squared minus 18x plus 81. At first glance, that's just like the same thing you've been doing. I need two numbers to multiply to 81 that add to negative 18. Is it 1 and 81? Is it 3 and 27? Oh, I like 9 and 9. So if you say both have to be negative, x minus 9, x minus 9, negative 9 times negative 9 is positive 81. Negative 9 plus negative 9 is negative 18, so it works. The only difference is here that both of these are the exact same, and you could rewrite it as x minus 9 squared. It's a little simpler, but also that's going to help you later on when you learn something called completing the square, and this is something called a perfect square trinomial. So let's see if you can try out the next one. X squared plus 10x plus 25. Pause the video, give it a shot, and we're back. Did you get x plus 5 times x plus 5 or x plus 5 squared? If you did, you are correct. So aside from helping you on this thing that you haven't learned yet called completing the square, the other thing that could happen is you could get some harder ones. Look at this, 4x squared plus 12x plus 9. This is a little trickier, but you might notice that the first term and the second term are both perfect squares. What do I mean by that? I mean, what multiplies by itself to get 4x squared? Why, you could do 2x and 2x. How about 9? What multiplies by itself to become 9? You could have 3 and 3. And sure enough, if you were to FOIL this out to check it, you would get 4x squared plus 12x plus 9. And that is another example of a perfect square trinomial. So when you see that first term and that last term, and they're both perfect squares, it's worth seeing, could I factor it using this pattern? All right, that's perfect square trinomials, not too crazy. How about something like this, x squared minus 81? The first thing you should notice is, ho, looks like we're missing that middle term. We used to have 3 terms in our trinomial. This is actually a binomial with only 2 terms, but your process is going to be the same. I need 2 numbers that multiply to negative 81, and it's going to be 9 and negative 9. So if you do x plus 9 times x minus 9, what happens is 9 times negative 9 is negative 81, but when you add up those two terms, you get 0, which is why there is no x term in the middle. You get just x squared minus 81. Again, you might notice that both x squared and 81 are perfect squares. There's something that multiplied by itself would equal that. And that's the idea of difference of squares. Oh, look, the answer has a different order than mine. Still all good. Multiplication is commutative. Let's try another one. Same idea. It's going to be 2 terms, a difference of squares. I'll pause the video here, or you can pause it, see if you got it. And did you get x plus 12 and x minus 12 is your answer? Again, if you wanted to FOIL this out, you could check it and you'll get x squared minus 12x plus 12x minus 144. Those cancel out. So that's your x squared minus 144. Again, not super horrible, but this is one of those where you need to actually recognize it. Otherwise, you might get stuck. What if we made it a little trickier? 49x squared minus 25y squared. The pattern's the same, though. We know that 7x times 7x would be 49x squared. I know that 5y times, in this case, negative 5y would get me negative 25y squared. And if you were to FOIL that out, it would still work. So this is another example of difference of 2 perfect squares and how you factor it. All right, let's do one more. How about if there's a plus sign there? X squared plus 36. So let's try what we've been doing. Could we do x plus 6 times x minus 6? Nah, that's going to give us x squared minus 36. What if we went positive with both? x plus 6 times x plus 6. Well, if you multiply that out, you're going to get x squared plus 12x plus 36. Huh, this is quite the conundrum. Well, it turns out that this one actually cannot be factored. So we've talked about perfect square trinomials and difference of squares. Well, this would be a sum of two perfect squares. And it turns out that sums of two perfect squares, two terms, just like this, cannot be factored. So these are true, but don't work for x squared plus 36. And right now, you're probably wondering, could I have some mixed practice? And the answer is of course. So why don't you pause the video? Why don't you try these four? And when you come back, I'll see if you have the right answers. All right, you ready? This first one is going to be y plus 2 squared. The second one is a difference of squares. It's x plus 2 times x minus 2. This one can't be factored because of that plus sign in between the two terms. And then this one, this was tricky. It's a perfect square trinomial where it's 3x minus 8 times 3x minus 8. So that is special factoring, perfect square trinomials, and difference of squares. Thanks.